So this presentation we're going to continue on with our branch-inbound maximization problem. So we're a good bit of the way through the problem. We're down here at nodes 2C and 2D. Essentially with the last presentation we looked at 1B. We come up with a solution. X2 was, well, we put in a bound here, X2 is greater than or equal to 3. We got a solution. Now the other part was X2 was equal to 3 or something like that. So at node 1B. So what we're going to do is split a branch on the variable x1. So what we're going to do here is we're going to set up two sub-solutions. X1 is less than or equal to 6. So that's node 2C. And x1 greater than equal to 7, and that's going to be node 2D. 2A and 2B we're not looking at all because we had an optimal integer solution at node 1A, so we don't have to continue down that subtree. Here we had a non-integer solution that was optimal, so we have to sort of branch on that. Okay, so node 2C, essentially what we're doing here is we're going to, where is my solutions there? The node 2C, there we are. Oops. Node 2C, essentially what we're going to do here is, this is from the earlier on, we imposed this additional constraint. Now we're imposing this constraint as well. X1 is less than or equal to 6. Now, just as a remark, you might notice that this constraint here is now redundant. Okay? Don't need that one anymore. Okay. So all the other constraints are applied that we have. We don't need an integer solution. We're using LP relaxation. But essentially, non-negative values. X1 is less than or equal to 6. 2x2 is less than or equal to 10. X2 is greater than 3. And the main one there, 2x1 plus 4x2 is less than 25. And we have to maximize 3x1 plus 5x2. So what I'm going to do now is I'm going to go to my set of possible solutions. It's a multiple choice question. So it's node 2C. Okay. So first off, what we have to do there is pick out, essentially, if you just check your constraints, some of these are very obviously going to be wrong. Okay. So it's just sort of, can you check them straight away? So node 2C, x1 is less than or equal to 6, okay, and x2 has to be greater than 3. So x1 is less than 6. So automatically we can get rid of that one. We can get rid of that one, okay. And x2 has to be greater than or equal to 3, so we could get rid of that one, okay. So what we have are these two solutions. Let's check them out. So we look at the other constraint there. That was 2x1 plus 4x2 less than or equal to 25. So 2 times 6 plus 4 times 3.25. That's 12 plus 13, so that's equal to 23. That's okay. 2 times 5.5 plus 4 times 3.25. Okay, that's going to be equal to 22. Okay, so that's okay as well. Now, what we will do here is, essentially, I'm just going to sort of cut to the chase here, and I'm going to sort of say that this one is feasible, but this one's going to be the optimal one, okay? They're both feasible, so but this one is going to be the optimal one, okay? They both obey the constraints, but the option 4 there has the higher. Option 4 there is going to be the higher in terms of optimized values. Okay, so in terms of the maximizing the objective function. So what is the objective function? Z is 3x1 plus 5x2, and that is 3 times 6 plus 5 times 3.25, and that is going to be 34.25. Okay. Now, the next thing we're going to look at is node 1, 2D. Okay. And in node 2D, what we're going to do is we are going to impose the constraint that x1 has to be greater than or equal to 7. And also, there's the additional constraint that x1 has to be less than or equal to 8. So it can only be either 7 or 8, or between 7 or 8. Okay. Also, x2 has to be greater than or equal to 3. Okay. So, let's keep going with that. So essentially, here is our solution set. Okay. So they're all, in this case, we can automatically sort of get rid of this one, okay? Because x2 has to be greater than or equal to 3, okay? And so, I just realized one there is carbon copy of the other. So 7 and 3. So all we're going to do is 2x1 plus 4 times x2, is that less than or equal to 25? That's what we're checking here. So 2 times 7 plus 4 times 3, okay, is that greater, that's less than or equal to 21? And let's just check that, because I think I've made a mistake. What is 2D? Greater than 7, greater than 3. And they 4 times 3 plus 2 times. Yeah, sorry, nope. A bit of bad mental arithmetic. Sorry, that's equal to 26. No good. Okay, I just got a little bit of a panic attack there. 2 times 8 plus 4 times 4. That's going to be like something like 32. No. Okay. 2 times 7 plus 4 times 4. That's number 4 there. That's 28. No. And 2 times 7 plus 4 times 5. That's equal to 34. No. Okay. None of them are feasible is what I'm sort of saying. None of them are feasible. Okay. And by the way, in a situation like this, if they are feasible, if there is a feasible solution, you would be given it. Okay. Now, so if there is a feasible solution, you would be given it. Okay. So none of these are feasible. So let's go to our tree. So we're going to cut this one off altogether. Not feasible. Okay. So that one's not feasible. So we got an answer there at 2C. So what we're going to do in the next presentation is just branch through that. Okay.